Thank you, ladies and gentlemen. Welcome from me as well to this session. Let me say thank you to the VI Grade family, first of all, for arranging this new event and for gathering people from the vehicle dynamics community and fostering these interesting discussions. Now, the thing is that the game is changing quite a lot. The European Parliament decided to stop fossil fuels and internal combustion engines and switch to zero-emission vehicles from 2035, which is actually tomorrow from a vehicles manufacturer's point of view. So this is making it all happen faster and faster. And on top of that, we have ADAS, autonomous driving assistance systems, and autonomous driving in itself that will probably play a major role in the near future. So with this in mind, what I wonder is electric mobility is changing the focus of ride and handling development. And we would like to know the opinion of experts on this. But even more into detail, I'm very interested in what is going to happen to subjective aspects of driving, like driver and passenger perception, for instance, during the use of the vehicle. And most of all, the words fun to drive, are they going to be still meaningful in the future? And for meaningful, I mean relevant for the automotive market. Is this going to change even today or in the near future for electric and autonomous vehicles? Because actually, someone recently said that we are all going to drive smartphones with wheels, which is not very nice in perspective. So is this really going to happen? By the way, let me remind everybody that VI Grade just published a white paper on this subject, which is really very interesting, according to me. The white paper is especially focused on the role of simulation and driving simulators in the workflow of electric vehicle development, so the development of vehicles that we are going to drive in the near future. Today, we have a panel composed of top-level people from top-level companies. I would like to introduce the first of them. Is Mr. Giulio Tarquinio, Senior Manager for Vehicle Attributes at Tesla. Hi, Giulio. Nice to see you here. Actually, Tesla was really the game changer when it comes to electric vehicles. Tesla cars are luxury and high-performance cars at the same time. So I guess that your job of definition, the vehicle attributes at Tesla is very challenging. And of course, we refer to ride and handling in particular, and to the related workflow. Can you tell us something about your job and especially about vehicle attributes with regard to the Tesla cars?
Absolutely. Hello, Marco. Hello, everybody. Yeah, you're absolutely right when you say that Tesla vehicles, and I think in general as an architecture, this new world of EV brings us a new challenge in terms of performance availability on segments that we were not used to, let's say, see with this level of performance. Is something that Tesla's been facing probably from the very beginning, and it's something we really care about. Now, your question, of course, is very broad. It's something, and especially what you said in the beginning regarding even future trends in terms of how we're going to position these attributes will change. But I was thinking maybe I will give it a spin on how things, at least nowadays, where I think the human-driven vehicle is still key, is still something we chase from a something very important from an attribute perspective, and I'll kind of give you my spin on it. So look, in the end, this trade-off is very clear. And we have vehicles which have very high performance, but at the same time, they sit into a segment where this performance usually is not available. This means that when you look at attributes like vehicle dynamics, NVH, range, aerodynamics, the drivability of the vehicle, you basically have to find trade-offs where the expectation, at least from us in Tesla, but I think is the customer expectation as well, is that just the breadth of ability of these vehicles have to increase a lot. So if we were used to the idea of, okay, performance will definitely come at the cost in terms of maybe efficiency and comfort, this is really not what we are targeting in Tesla. What we want is to limit this trade-off as much as possible. And the idea somehow is that going higher end, yes, you unlock performance, but that doesn't necessarily mean that you're taking a trade-off on your cost of ownership or your everyday driving experience from a comfort perspective. So then the question really is, how are we doing this? I think that to this, there is what I call the easy answer, and probably something we all think about, which is, yeah, we can go active. Okay, we can develop active systems, because active systems are very good at bridging these gaps. Basically, you take something that used to be fixed, now you make it variable, and if that characteristic was driving one of these trade-offs, then all in a sudden we are able to open this trade-off more and more. And the other thing which I think is interesting with EVs is that, of course, we have quite high electric power availability. So when I think about typical, even my previous experiences before Tesla, we're looking at high-powered chassis controls, we will have probably bigger challenges in terms of justifying electronic architectural changes that could make us use higher powered active systems. While on EVs, I think this is an opportunity, because normally we can access this kind of technology with with less impact and less challenges on a program level discussion. Still, if we think about niche market, this is the answer, I think. When we think about mass market, all these systems really come at the price in terms of cost and mass. So I don't think that can be really the final answer to the question and the challenge. And that's why I think that even before getting there, the most important thing is really analyze the EV architecture and its characteristic and what makes an EV different from an ICE architecture. And examples around this could be things like, I don't know, low pole and inertia, low COG, higher mass, very different powertrain response and characteristics. And in the end, all of these things, for example, the mass, probably from a ride and handling perspective, brings more challenges than opportunities, but other ones definitely bring opportunities. And I think that what this means is we have to really go back to the first principles and try to understand on a very high level architectural discussion, what is really different? What are the main opportunities, the main doors that open because of an EV being different as an architecture? And then can we actually use this as a way to first of all, deliver what we said, which is basically the best possible attribute trade-off. But then at the same time, can we use this to differentiate our DNA and make sure that even if we are leading probably towards a world where people think more about the smartphone, as you were saying, but still we want people to recognize what they're driving, that they're driving a Tesla and not, let's say, another vehicle. So from a workflow perspective, I really think that going back to first principle is the most important thing, because I think that anybody which maybe has been in the industry for a very long time, I kind of assumes that what has been working in the past is going to work today and work in the future, might find himself in front of more of a challenge. I think going back to the basics, analyze on first principle what this means, and chase these risks and opportunities is really the key. And so that's the first part. The second part, I think, is probably interesting for this seminar, and what we're talking about is, okay, but then we still have to chase something really optimized. And then that's where I think the simulator plays the very, very important role. Because as we said, we go back to first principle, we find maybe opportunities, but then at that point, the question can become, okay, now I'm kind of going out of my comfort zone. So let's take, I can make many examples, but probably suspension, kinematic, and compliance. We can take an expert. That expert will definitely place the vehicle in the right ballpark for what is targeting. But normally these approaches, for example, might be conservative and might be really focused on those trade-offs we said at the beginning. We want to develop a sports car. This is the suspension we develop. We develop a comfort-oriented car. This is what we develop. So how do we try to start going around more difficult, or let's say, or risky areas? Probably areas which we wouldn't explore in the past. And I think that's really where the simulators plays the big role, because when you take these decisions, normally you are in a phase where the long lead items, those components, which normally you have to freeze even before you get a test vehicle, so don't exist. I mean, you don't have a vehicle to test things. And so that means I either go conservative or accept a huge risk down the road. What the simulator can do is, if you spot one of those opportunities, if you see something where you think going against the standard trend might be the right thing to do, you can use the simulator to confirm that what you have in mind is a good idea and reduce massively that risk that then you're bringing, considering that you are already freezing long lead components before trying it, let's say, on the on the physical vehicle, let's call it like that. So that's one thing. Just to close on this, I think the active systems still are super important. And that's, again, where simulator comes into play, because, as I said, architectural optimization is really the key. And being able to develop both the hardware and the active side together can be very important. So examples like driving simulators, software in the loop, trying to chase optimization of our passive hardware while already knowing what will be the active system capability of the vehicle is another interesting area. And at the same time can basically bring the development forward and accelerate a lot, for example, from a testing phase, all that initial debugging, initial high-level, control strategy, let's say, development, where you can start from a much better place and end up in a much more efficient testing phase. Testing and, let's call it fine-tuning phase at that point. I don't know if this answered the question.
Well, actually, it was a broad question, and it received a proper answer, I would say. Thanks a lot for this. And I'm really glad to hear that the human is still, at the center of the development, either not only on the driver in the loop simulator, but also as a driver on the vehicle itself. Thanks a lot, Giulio. And I will go on to Tomislav. Hi, Tomislav. Welcome on board. You are actually responsible for vehicle dynamics and performance at Bugatti Rimac. And this is actually very interesting, because I believe that Rimac was the first brand and maybe the only one so far that succeeded in building a full electric supercar that is actually market ready. We are talking about, let's say, can we speak about hypercar or supercar? I don't know what is the exact definition of that. And even more interesting, you are one of the men who made Rimac what it is today. You told me that you were employee number 10 in Rimac back in 2010, maybe around that. And today there are 1,300 employees at Rimac. So things evolved quite a lot and very quickly. So my question for you is, what I wonder is words like vehicle response, handling, steering feedback, all these words involving perception again. are they going to be lost along the way and forgotten in the future, or are they going to stay with us for a long time again?
Hi, Marco. Thank you for the introduction. Just correction. The spelling is always Rimac, and yeah,
Okay. Sorry
we are
about that.
in a hypercar. So yeah, we built the first hypercar before 10 years. But I see Boris is looking. There is other players on the market these days.
Yeah, we are starting to do so. Yes.
Yeah. Just to back on your question. I think electrification is just the mid step of between the development of the full autonomous vehicles, and I strongly believe this revolution in transportation will happen, and this will bring many good things we already know. I think it will reduce the number of accidents. Overall efficiency of the transportation will be very much increased. But on another side, yeah, there is always question of the drivers, also vehicle dynamics engineers. I believe all of us, what will happen with drivers in the future? I think they will not disappear. So there will still be drivers in the future. I believe most of the industry, most of big OEMs will concentrate on the development of fully autonomous vehicles. So the cars without the commands steering and the brakes, and this is for sure. But also I think that some brands will still developing the cars for the drivers. Also maybe some OEMs smaller special segments. I think this will be something what can happen in the future. And your question, if this all driving aspects will disappear, for sure, I think it will not disappear. Maybe, but for sure they will change. And with this all electrification, through the history of automotive history, we have all the time changing the driver aspects and customer let's say wishes. If you take any vehicle dynamics book before, I don't know, 20 30 years, and you are lucky to find some objective data of some cars inside, then you can see that how this data compared to what we have today, cars are so different in so many ways. So the cars increase response, many technical stuff. I think this will continue is also in the future, and already this is happening quite a lot with electrification. I can give you just one example. I remember before 10 years approximately, when we did the first prototype of concept one, it was first electric vehicle with 1 megawatt of power with 4 individual motors. I remember when we did first testing, and then there come subjective drivers with some experience in that time, hypercars, also with some racing experience. And I remember the comment of one of the guy told me, they were completely blown away with the performance, and this was not surprising considering but this was first time they experienced the response and everything from the car. And he told me, okay, first couple of laps I was a little bit scared of this, but after that I started to like this thing. But he told me, still, for the customers today, I think we will need to reduce all this response and try to make from digital car a little bit more analog. And he was right. I think in that before 10 years the drivers were not ready for this performance. But after that happened, Tesla. Okay, now it's a lot of people driving Tesla, Porsche Taycan, many cars, and I see that driver perspective already changed, and people are starting to be used on that response from the electric cars. So I would say, just to answer on your question, I think driver aspects will change, and it will continue to changing like through the whole history. In my opinion, the part which will still do the development part, which will still do the cars for the drivers. The biggest challenge for the vehicle dynamics engineers in the future will be to find the good balance between driver involvement in the driving and active systems. We already see now in these days, sometimes you have the journalist telling, oh, car is like great, it's easy for drive, I can do very, very good lap. But on another side, it's I'm not enough involved in the driving, and it's not fun to drive. I think for this portion of vehicle dynamics engineers will be I think this will be challenge to find the right balance in the future. Also, okay, if we compare with, for example, what I mentioned, the drivers in the future with, like today we have horse riders. I think there will be some other features in the car which will be invented. For example, we are now developing for the new Nevera driving coach. This is the feature which help you on the racetrack to teach unexperienced driver about the braking points, the lines, and I think even I think this kind of features, maybe new generations of drivers will attract to still continue to driving on the car, but just on the racetrack and in controlled environment, not in the public roads.
Okay. Thank you, Tomislav. I really like this idea of the driving coach because I've been doing this for many years as a human, actually. Coaching drivers, race drivers to be faster and brake later. Okay, thanks a lot. And we'll go on to Boris now, Mr. Boris Kirchner from Lotus Cars. Kirchner, is that
Hi, Marco.
correct?
Yeah,
Hi, Boris.
Kirchner, but call me Boris.
Okay, Boris, sorry about that. It's very good to see you again. You were a panelist of mine last year as well, and I know that your point of view is extremely interesting always, because you've got extensive knowledge and experience on ride and handling development on various programs from different cars, different manufacturers as well, Porsche, Mercedes in the past, and so on. And actually, you now lead the vehicle dynamics and chassis team at Lotus. And actually, when we can see that on your background as well. And when it comes to the fun to drive factor, actually the name Lotus is the first that springs to mind. Light cars like the LEs or even the 760 years ago. And I think this is making your job a huge responsibility. Can you tell us something about your job, what you are doing now, and how you approach this challenge?
Yes, yes, of course, Marco. So yeah, Lotus is famous for its lightweight sport cars. Yeah, and I think the icon is the Elise. The Exige is a great track car. Now we are developing Electra. This is a beautiful car you see behind me, and the marketing optimistically called it a hyper SUV. So it will be like we have seen the cars from Rimac. I hope the pronunciation was
almost
okay.
Rimac.
Rimac. And this performance also we know from Tesla cars before. It's now spreading out to different segments. We know in the past 10 years SUVs become super popular. And we have seen that also traditional sports car brands like Porsche moved into SUV business. Even Lamborghini made a SUV. Ferrari is coming with one. Yeah. And I think you cannot make a good business case in business and automotive industry without these SUVs. Then, okay, how do we transfer the classic Lotus DNA of lightweight feel, of connected feel to the road onto a more than 2-ton SUV with over 600 horsepower? That was a very challenging and interesting question from my team. And first of all, we had great support by also the whole team at Havel around Gavin Kershaw and other great vehicle dynamicists. So when it comes to the Lotus DNA, it's always important you feel that direct connection, you feel that linearity. And as we might know, it's different when you have this big battery pack along the driver. So first of all, we start designing the kinematics, the suspension. And what you can judge, it's I think if you want to be best in class and leading, there's no idea about overtaking a suspension design from a given architecture like we have seen on other Geely or Volvo architectures, which we considered in the beginning. But then very soon we came to the point where we said, okay, this need to be a dedicated, bespoke architecture. So we have developed a completely new 5-link front suspension and rear suspension. And this gives you a lot of freedom, but also a lot of complexity. So you have a lot of things to tune, to tweak. And also then when you release first time the full power to these vehicles, it's quite interesting, and you got a lot of different side effects, like Giulio mentioned. It's different from the classical ICE approach. And also, if I remember back my time at Mercedes, when I really had the first demo or prototype or mule vehicles, normally they had always the highest torque and highest performance. And then after the drivability tuning on the V8 or V12, that derated a little bit before production. On the BEV vehicles, at least at us, but I know it from other companies, it's normally other way around. So in the beginning, you start with very limited performance because you need to learn your cell symmetry, you need to understand the battery, you don't want to overheat your propulsion machines, and so on. So you release the performance step by step over the development. And with each new step in performance of the vehicle, you see the new challenges you have in terms of road contact and feedback to the driver. But here we are using simulation, online, offline simulators quite well, quite often, and it helped us a lot to maintain this complexity.
Okay. So I can see actually simulation and driver in the loop simulators are fully integrated in this complex development process.
Yeah, for sure.
Okay.
They are. Especially in the early phase, we use them a lot as a forecast pre-tuning. Now, as we are close to production, we have changed the scope. So now it's more or less we use them to sign off all our electronic system or the control system. You have a wide variety. So we use the simulation more also in a forecast to also make sure we fulfill homologation requirements for functional safety and these items. So more in a quality term of sense.
Yeah, I can see that. Also, in my experience here at the university with the simulator, this is the two values of the simulator that are most evident, and quite often on one side you've got driver subjective aspects, and on the other side it's system integration, and it's a very powerful tool on both these sides, for sure. And thanks a lot, Boris, for now. And finally, we have Mr. Richard Hill from Horiba Myra. Hi, Richard. Good to see you again as well.
Hello.
Actually, you are Chief Engineer for Vehicle Dynamics at Horiba Myra. Horiba Myra, everybody knows that it's an engineering and testing facility in the UK. Well, actually, I really know that you have a broad view on the development of vehicles and vehicle attributes in particular from very different manufacturers. And what I would like to ask you, considering the range of electric vehicles that Myra has contributed to develop to date, and also looking ahead to the adoption of autonomous driving, do you feel that the typical attribute-driven development approach, which is, let's say, peculiar of Myra, will still be valid in the future?
Thank you for the question. First of all, I probably ought to explain what we mean by attribute-driven development.
Yeah.
So attribute is a quality or feature that the end user regards as a significant characteristic or feature of their vehicle. So attribute-driven development is all about focus on that end user experience, with the entire process driven by how the end user will perceive the vehicle when they use it in their own way. It's got to be remembered, though, that customers of different types of vehicles, different markets, etc., have different usage profiles, different vehicle requirements, preferences. Hence, they'll perceive the same vehicle differently. So you've got to understand the customer you're targeting and what their preferences are. In addition, as already been mentioned, customer requirements and preferences evolve over time. They have always. I've been in the industry many years. When I first started, we were even on manual steering, never mind ABS and stability controls, etc. It just continually evolves, and customers build on the experience and move on to the next level of experience. With regard to the range of electric vehicles Myra has been involved with development of, a significant number of those early vehicles were relatively simple vehicles, and the customer requirement for those was fairly straightforward because they had no experience of electric vehicles before. So their experience was all based on the current internal combustion engine vehicles they're driven, their experience. They wanted to extend, they knew they wanted something better, but they didn't know quite what to expect and what their requirements were. They knew where to like to go. So our challenge on those first programs was, how do you actually achieve that internal combustion engine type feel and performance from a battery electric vehicle? And that, as we're all aware, has its own challenges. However, other projects as we move forward, because we've actually done quite a lot of battery electric vehicles, probably more than most OEMs because of our involvement with a number of different customers. They've been for customers in slightly more mature markets where customers have some knowledge of how a battery electric vehicle feels and potential benefits, and clearly they're looking for that improved experience. So their requirements have evolved, and they're just looking for that bit more. So really, that's a case of understanding the customer for that particular market, for that particular vehicle, incorporating the position of the manufacturer working with, so you incorporate their brand DNA into it, and aligning that to your program targets subjectively at a higher level, and then carrying that through to ensure that you deliver what the customer wants. As you move forward, the adoption of more sophisticated powertrains, active chassis systems, drive rates, etc., means it's possible to increase the dynamics performance envelope where the end user requires it. Again, a key point where the customer requires it. Not a case of throwing every system on every vehicle. It's what's appropriate for that end user's requirements. It's got to be remembered that the performance of all these individual elements, individual systems, also contribute to the customer perception of the total vehicle. So the systems need to be developed in harmony with the base vehicle attribute. And I think that comes back to, again, a point made earlier. Getting the base chassis right, getting the base configuration right is key. You can't just take a vehicle and throw systems on top of it as sticking plasters to try and cover up problems. It needs to work in harmony, it needs to work together. Following the attribute lead approach, the design vehicle level performance is first established subjectively. That's what the customer feels. It doesn't matter what the numbers are at that stage. What the customer feels is what he'll make his decisions on. If he doesn't like it, and if he doesn't like it as a customer buying a car now, or as a ride-hailing person later, or whatever it is, if he doesn't like it, next time he'll potentially choose something else. So the customer is important. So I've just lost my flow of thought there for a second. So establish subjectively, and in order to make sure that complete package works, you have to actually incorporate all those systems you're going to fit onto the vehicle in your generating your objective targets, and for the whole vehicle, and from those the system requirements. Again, it's no good saying, okay, we'll just develop a base vehicle, then we add these things in later. You need to actually right up front decide what each system is going to contribute, how they're going to interact, and where's the best value for the customer in how you actually make those work together, and what you do and do not include. This is, again, one of those obvious places mentioned earlier where a driving loop simulator really helps you make those subjective evaluations of the targets, of the contributions. So at this stage, models of the powertrain, active systems, etc., are relatively simple. So they just provide the basic function, but that's sufficient that you can understand the basic contributions and set some targets for the systems, so the teams can work to those initial targets. As both the mechanical design and the control system strategies and calibration develop, the performance of all areas is monitored at system level, but most importantly, brought back and evaluated subjectively at the vehicle level to ensure that they're not drifting apart and to reconfirm your initial targets. In that way, again, you're continually monitoring that end user's impression of the vehicle, their perception. Again, as you progress through this program and you move from your initial models, what have you, to a more sophisticated, you end up with a driving loop, hardware in loop, etc. when you get to the end to finally arrange that. Just highlighting ADAS functions for a moment. In the past, some companies have merely developed these completely separately from the attribute, and then ended up with inconsistent, non-harmonious vehicles, where the customer's not really appreciated the benefit of the systems, and more often than not has actually wanted to turn them off, and is effectively switching off something he's paid for and getting no benefit for. So clearly, a join-up approach is required to give that complete customer experience. With regard to the effect of increasing levels of autonomous driving, this is starting to have an impact on programs. It's not surprising that the customer's preference and requirements that we know evolve with the external influences will be affected by this and are being affected by this. The question is, what effect, how big, and when is it really going to come in? Level 3 autonomy and below, what we've seen, it's having some effect, but it is quite limited. Principally, I think, because ultimately the customer's got to feel confident with the vehicle, he's got to be familiar with it, he's got to feel that he can take control of the vehicle, it's within his normal realm of experience. Therefore, it's been a relatively sort of steady evolution rather than a quantum shift in the requirement. When we come to level 4, we see a increased separation, in fact, of vehicle requirements, where you have certain vehicles target for specific roles, which have a clearly defined operating case and what have you. Again, users ride hailing or whatever, but within a clearly defined area. And those are moving a reasonable way outside the current expectations of a normal vehicle. That they are moving to a new area. But I think what we're really seeing there, as much as anything, is the introduction of new classes of vehicle rather than a change of fundamental customer requirements for a particular type of vehicle. I think the vehicles, the more normal mainstream vehicles will continue to have, rather than perhaps the quantum shift that they see on the specialist vehicles, more an evolution. It'll be quicker than it has been, but it will be more slow because it's that confidence that the customer has that he can take small steps. He's happy with that, but the big jump, if they're going to purchase a vehicle, they'd be reluctant to make. What you've got to remember, though, is that I'm talking about a general shift in all vehicle characteristics, or the general vehicle characteristics. We still will have very different requirements for the normal different classes of vehicles in different markets. Even when you get to level 5 autonomous vehicles, I personally feel that we'll still see a range of customer requirements or desires for different dynamic experiences. Despite there being no need for the vehicle to control the vehicle, I think they will just want a different feel to the vehicle. I don't believe everything will be purely ride-based, as some people predict. It's not just about that. Some people want to be more involved, be it a pseudo fairground ride or whatever. But some people will trade off, I'll take 10 minutes long on my journey and have ultimate comfort that I can sleep through it. Other people want to get there quickly, be involved, enjoy the ride. There will be a range. So we will see different characteristics. There will be different requirements from customers. It always needs to be remembered, though, that even though it's as a fully autonomous vehicle, you can argue, well, why does it matter? Purchase of vehicles has always been a mixture of rational decision and emotion, and that will stay. And in addition to that, OEMs will always want to differentiate themselves, and it's something we clearly see with the different companies we work with, to get their brand, to get their DNA. And the emotion of the vehicle's movement and action, what have you, is a very strong identifier. So in answer to your question, the objective of attribute-driven development is for the end user to perceive that the vehicle satisfies their requirements and preferences. Customers' preference and requirements will continue to evolve. New classes of vehicle will be introduced, as I said, for sort of specialist areas. And as such, the target dynamics performance will change to a degree, but attribute will remain important to customers, and it's customers, at the end of the day, that drive the market.
Yeah. This was very, very interesting, Richard, and I think keeping up with the evolution of driver and customer expectations is going to be a very tough challenge in the future, and this evolution will be faster and faster, and will be, it will go up when the vehicle changes. The expectations change a lot as well, and this is extremely interesting. This will be the key factor in the future. And but apart from the human factor, I would also like to ask one of you about another key factor in vehicle dynamics. Unfortunately, we've got only a few minutes left, and people at VI Grade, I think these webinars should be twice as long as this one, because it's very interesting, but we never have enough time to go deeper into what we discuss. tires and tire models, that have always been the key to reliable vehicle dynamics simulations. Are they evolving as well, tire models, for the new challenges? Heavier vehicles, a lot of torque, and the need for even more precise and accurate models. Who's the one who is going to answer? I can see Boris is interested in answering this.
Yeah. So we are using quite now also a variety of tire models. So what we have seen is there's no one fit all model. Yeah, for sure. For more real-time applications, the magic formula model, Pacheco models is, I think, still state of the art. But we have seen many effects where the tire physics come into mind. Yeah. And they start from ride comfort, NVH. So we are going into more wider frequency ranges when it comes to deep coupling of the powertrain system from the secondary ride eigenfrequencies of the wheel and tire environment. Then I think we need more sufficient tire models like the F tire models. We are using that quite well. We're trying to introduce it also more and more into dynamic aspects. When it comes to the tire road contact, we try to get a better understanding, because for us at Lotus, the steering feel is super important. Yeah. And on these cars, if you want to design a steering feel on a heavy car with all the active systems, you need to understand really what's happening in the tire contact patch, how the physics is going on there, and also how very small kinematics or electrokinematic effects have an influence on how the tire contact patch looks like in dynamic maneuvers. And here, I would say we are just at the beginning. I expect in the next 10 years, here even tire models become more and more complex, but also coming more and more close to reality, what happens there. Very interesting approach we see with the intelligent tires. So tires where we have sensor elements directly in the contact patch. I think McLaren is now starting with a first approach on a serial car, and I know others are coming as well and interested in this technology. And I think what we will see there is then also cloud-based, using artificial intelligence. So from the real fleet of the car, doing like big data analysis and tire model matching. And this is what I expect as a vision for the future. We will not put that one single tire on one test bench, but learn more from swarm data from all our vehicles about the tire physics.
Okay. Thanks a lot, Boris, for this. Just very quickly, Giulio and then Tomislav. Does what Boris said right now, does it mean that tire manufacturers will be more and more involved in the vehicle design stage and in the simulation on driver simulators, vehicle models, and so on? Do vehicle manufacturers need tire manufacturers to be more and more involved? Giulio, please, first, and then Tomislav, but very quickly. I'm sorry about that.
Just 2 cents from my side. I think that's absolutely the case, and it's not something new. It's really a phenomenon that has been very clear in the last few years, where let's say the simulation, the simulator use, all of this probably has started at OEM. What has been happening just after that is that tire suppliers have realized that it's so important to follow the trend on the supplier side as well. And that's why you can see very clearly that as today, basically every tire supplier is investing a lot in terms of their capability to virtually develop tires. They are looking at simulation environment. They make sure that they can use the same models as us, as OEMs, and same with the driving simulator, because in the end, we are always going towards stretching the timelines. We want to limit testing as much as possible, and as we said and as I said as well in my first answer, I think we really need to get the right we don't have really the time anymore to reopen big items. And being the tires, probably the number, I mean, whatever we do from a vehicle dynamics perspective, we want it or not, is going to go through the tires. So it's such an important component that it's impossible for it to be outside from this loop. And yes, tire suppliers are already fully investing in it. I think the intelligent tires is a very good point from Boris. That's something that is evolving. And that's another area where, again, it's not tire supplier alone. How successful this kind of technology will be around how much tire suppliers and OEM will be able to work together to take the best out of it. Because I don't think either of the two can basically get the most out of it without a full integration.
Thank you, Giulio. Tomislav, what's your point of view on this?
Yes, I agree with both Giulio and Boris, and they already answered the most of the questions. So I think the most tire suppliers these days, also for hypercars we are working on, it's involved in the well-known V-shape development design and using of simulator from early beginning. So how we are doing, we are developing a vehicle together with the tires, starting with some proposal from tire manufacturer, and then manually and very quickly change the characteristics. For example, okay, we can start with MF 5.2 or 6.1. And and there was like every 3 to 6 months we have communication more deeper with the tire manufacturer to check how far with some of these characteristics. I know with we can coordinating stiffness, maximum grip, relaxation length, how far we can go from the baseline to reach the targets of the vehicle.
Okay, very good, thank you. And I feel the simulator is really the meeting point between the vehicle manufacturer and the tire manufacturer. Is that right? Is that correct? Boris?
Yeah, absolutely.
Great, thanks a lot for this. Thank you guys. And I think this is the right time for the Q&A session.
Thank you to everybody who's able to answer and do the panel so far. We now have time for Q&A. I see a few questions have come in so far. What will be transformed for the future of heavy trucks?
Who's going to answer about heavy trucks?
I heard Tesla is doing some.
Yeah,
that's right.
That's what it come to me.
Lotus will not do heavy trucks, so this is for you, Giulio.
Yeah, no, I think that it's I think that commercial transportation is something that is it's definitely not as developed as the standard general park EV market. Not only as Tesla, we have other players already in the field, maybe with smaller, let's say the van and truck market. It's something that is being under development for some years. And I think in the next 1-2 years, we will see more and more of this to come as kind of joint development, let's say between tech companies maybe and automotive OEMs, as in case of Tesla, again, it's collaborations, let's say with customers which are interested in this kind of product. Now, when it comes to the trucks, my personal opinion, I think that the attribute setting was already very different, let's say, between the truck market and the standard road car, just because you look at the priorities across the attributes is different. But I think that one of the main enablers will, no matter, and we tend to correlate these to EVs, is really the autonomous driving. I think that safety, in my opinion, is really the key, especially when it comes. We know very well how much transportation cares around safety and reliability. So let's say what will be different on the truck market for EVs compared to the standard road car? I will say that no mistake probably will be accepted from a reliability perspective. Mistakes that have been forgiven, I think, to every player in this field until today, to some extent, I would say. And on the other hand, the acceleration to full self-driving will be very, very important in that as well.
Thanks a lot, Giulio, for this. I can see two other questions in the chat. The third one we already mentioned, intelligent tires. So I would go to the second one, which is very interesting. Speaking about active chassis systems for massive EVs. I can't leave air suspension systems left out in this discussion. This is pretty interesting. Apart from added comfort for passengers, what does our panel think in terms of pure dynamics of vehicles using air suspension in EVs? Boris, maybe?
Yeah, on the SUV you see behind me, we are using air springs. So there are different advantages to the customers which go beyond just ride comfort. I think also in terms of NVH, high frequency isolation, they offer comfort which the customers of bigger E-segment cars just expect. But then in terms of feature levels, so you have definitely the different ride heights, which is also important for aerodynamic features, but also in offering different drive modes to the customers. Easy loading or easy entry functionalities getting more and more important. Yeah. And I think there are also special markets, especially when we come to Easter markets, that people like to show features. They like that their car is moving at standstill, can lower itself. You can raise it up even on your smartphone. You can interact with the car and you see a reaction on the car. I think this feature is becoming more and more important in many markets. Then secondly, just also other technical topics. If you think about inductive charging, I think in inductive charging, it's important to maintain a close gap. And let's say the automotive industry has not decided yet if the charger is coming to the car or if the car is coming to the charging plate. But definitely systems like AirSpring offer here new features also for more convenience on the EV cars. And maybe that's also as an outlook, very interesting feature which we also use is using multi-chamber systems so that you can basically switch between different ride rates. And on a comfort or tour mode, you can have lower ride frequencies, and then on sporty or track modes, you can increase ride frequency, which is basically something with a standard steel spring you would not be able to do.
Okay, thanks a lot, Boris, for this. Do we have time for just my very last question to Tomislav? El?
Absolutely, go for it.
Okay, thanks a lot. Tomislav, I know you are an expert on torque vectoring.
Yes.
You've got experience on that.
Yes.
And just before, you said that what we need is the correct balance between driver involvement and active systems. I mean, torque vectoring can affect vehicle behavior quite a lot. How can you find the correct trade-off between these factors?
This is a hard part. I think it's a lot of working with the drivers.
Okay.
Sometimes numbers don't help much because I know for example, in universities, research always doing this little bit, without a driver in the loop. And what I learned when I started, before that, I was doing the similar stuff on university, and the things were simpler. It looks simpler on the paper and in the simulations with virtual driver. But on the end, you need driver in the loop, and this involvement is very, very important. And I think the good understanding and connection between subjective and objective, it's crucial if you want to do a good driver's car. And I think in this the simulator, a great simulator like Motion One helps really a lot. So also understanding this balance, it's much easier.
Excellent. Yeah, this is a very interesting topic as well, which would require a deeper discussion. But I think we ran out of time. And Thank you, everybody.
Thank you, everybody who participated in our panel today, and also to VI Grade for supporting the events. That's all for today's session. So thank you all for listening, and goodbye for now.
Thanks a lot.
Bye.
Thank you, everybody. Bye-bye.
Everybody.
Bye-bye.
Bye-bye.